Hi ladies! So in this section 8.4 we're going to be looking at area of regular polygons. Remember we've already looked at area of triangles and quadrilaterals, and so now we're going to move on to other things. I just started you off with the area of an isosceles triangle is 48 square inches. The height from the vertex angle to the base measures 8 inches. Find the perimeter of the triangle. So again, just one of those using the area to find the missing measurement, then go on and find the perimeter. So if the area, I drew a little picture of our triangle here. If the area of the triangle is 48 inches squared, and the height is 8 inches, we need to find a couple things. We need to find the base, and then we also need to find the lengths of the other sides. So we're going to start with the base. Using our area formula of 1/2 base times height, we're going to set 48 inches our area. Equal to that, we know the base is a variable and the height is 8 inches. Again, you can do this a couple of different ways, right? You can simplify this side first or multiply by 2. And it turns out that the base is equal to 12 inches in this case. Now, remember that in an isosceles triangle, the height here is also the angle bisector, which is also the altitude and the median. So these two, that base segment has been bisected, creating two congruent subsegments. If this is 12, then this is 6 and this is 6. Now, figure out the length of this side here. If you notice, we have a very nice right triangle, a 30, 60, 90. Oh, actually, that's not true. We just have a right triangle. So we know one of the legs is 6 and one of the legs is 8, and that's one of our Pythagorean triples. So that leg must be 10. Now that we have all the information we need for the perimeter, we just add up all the sides. So we have 10 plus 10 plus 12. That means the perimeter of our triangle is 32 inches. For the investigation we're going to take a look at today, you're going to need the key term apothegm. And when I speak of an apothegm in this case, I'm talking of a regular polygon. So the apothegm is a perpendicular segment from the center of the polygon's circumscribed circle to the side of the polygon. And the length of this segment is also called the apothegm. So if I refer to the apothegm, I'm referring to that specific segment, but I could also be referring to the length of that specific segment as well. Again, if we look at the picture to describe what an apothegm is, here is our circumscribed circle, about this pentagon, and this would be the center of that circumscribed circle. So the apothegm is the perpendicular segment from this center to one of the sides. So it could be any of the sides. It's going to be that distance is going to be the same because, again, it is a regular polygon, which is, again, part of the reason why we specified that. Now what I'd like you to do is work through this investigation, pause the video, and then come back and look at my notes once you're finished. Okay, so I'm going to go ahead and go through with the investigation, assuming you did it. So we take a look at this pentagon here, and we have our apothegm, and we have our side, the length of our side, which we're calling S. What is the area of one isosceles triangle in terms of A and S? So the area of one of these triangles would be 1/2 base times height. But again, we want it in terms of A and S. So A is our height and S is our base. That's the formula, or the area of one of the triangles. Now the second question is, what is the area of the pentagon? So again, this is the area of one of the triangles. Because this is a pentagon and we've divided it into 5 congruent isosceles triangles, we can take this area and multiply it by 5. So the area of the pentagon would be 5 times the 1/2 AS, or you can think of that as 5 halves times the apothegm and the side, the length of the side. So looking at other regular polygons, you're going to come up with these formulas. So the pentagon we already did, so it's 5/2 AS. The hexagon is 6/2 AS, which actually simplifies to 3 times AS. For the heptagon, 7/2 AS. The octagon, again, it would be 8/2 AS or just 4 AS. And I'm going to fill in those other ones. And for the n-gon, right, it's going to be n/2 times AS, or we can write that, and this is going to come into play in the next part, as 1/2 ASN. Those are the same expression, the same formula there. The reason why I wrote it like this is if you look at the next part of the investigation, the question is, what is the perimeter of a regular polygon in terms of n and s? So I just want to go back to, I don't know why that's not erasing. Here we go. I want to go back to the picture of the apothem where we have the regular pentagon. So now let's look at this pentagon and let's think about its perimeter. So if this is S, and this is S, and this is S, and this is S, we have n sides of length S for the perimeter of this. So the question is, what is the perimeter of a regular polygon in terms of n and s? It's n, the number of sides, times s, the length of the side. And so when we think about the formula that we came up with before, that the area of a regular polygon is 1/2 ASN, another way to think about this is to replace the SN, or NS in this case, with the variable P, or perimeter. So another way to look at the area of a regular polygon is to take 1/2 the length of the apothem times the perimeter of this polygon. Those are the two formulas we're going to fill in. The area of a regular polygon is given by the formula 1/2 ASN or 1/2 AP, where A is the area, P is the perimeter, and A is the apothem. S is the length of each side, and N is the number of sides. That's our new formula. Exciting to discover. I have 3 problems for you to look at. In each of these cases, I want you to round to the nearest whole unit. And I also want you to consider looking at these, the way they're given to you in approximate measurements. And that's because really when we find the apothem, a lot of times we're going to be using, we could think of it this way, we're going to be using right triangles, and a lot of times those involve square roots. That's why we don't really have exact answers here. So a lot of times we're rounding the apothem to the nearest tenth, and then therefore the actual area itself is also rounded. The side length we can get to be a little bit more exact because we don't have to use the Pythagorean theorem to get that actual length. So what I'd like you to do is pause the video and try those problems, and then go ahead and look at my answers. All right, I'm going to assume that you've tried these on your own. As you can see, ladies, as I'm working through these, I am using the approximation signs, the squiggly equals, so to speak. So for the first one, we were looking for the area. We are given the length of the side as 24 centimeters, the apothem length as 24.9 centimeters, and of course we have to count the number of sides ourselves to find n. And again, a basic plug and chug. I start with my formula, I substitute all my values in, and I go ahead and simplify that. And again, rounding that to the nearest whole unit, it tells us that the approximate area is 2,092 square centimeters, or centimeters squared. In the second problem, I'm looking for A, the apothem. So I'm given the area approximately, I'm given the side length, and again, I have to count n for myself, which is 5. So I went ahead and set my area equal to my formula on the other side, substituting in all my values except for A. And then I went ahead and I just simplified this by multiplying it, and I used, plugged it into my calculator, and then find A, of course. I did an inverse operation and came up with 74 centimeters as the approximate length of my apothem. For the third problem, we were looking for perimeter. Now, this can be done in a couple different ways. You can solve for the missing variable, which would, in this case, be S, and then use S times N to figure out the perimeter. Or I would encourage you to go the more efficient route and use the second formula for area of a regular polygon, which is 1/2 length of the apothem times perimeter. So that way, you're just going to use that formula and solve right for P. You don't have to do two different steps. Again, substitute in my area, the length of the apothem, simplify that side, and perform my inverse operation. And I kind of forgot about the approximation here, so I am kind of making it a big deal for you. The perimeter is approximately 256 centimeters. There you have it. I look at our new formula, area of a regular polygon, in a couple different ways, and we are going to be looking at more problems in class, and then we will take a look at some more area formulas. Thanks, ladies. Make sure that if you have any questions, you feel free to contact me, and I will see you soon.